Okay, this is Algebra 1's lesson from day 24, Precision and Accuracy. The goal of this lesson is where students will apply precision and accuracy to measurements, okay? So, in math, it's really important that we are precise and accurate, right? Josh, put it down. Thank you. Noah, thank you. You could like this video now for that comment. Okay. Or dislike it. So, anyways, the totally awkward. Okay, so I'll make sure your iPads are done. So precision and accuracy is super important for. That's funny. The 6th and 7th period are gonna totally do that. You use precision and accuracy in math all the time, right? We have to. This is really important. We're always precise and accurate. When we build buildings and we build things in life, everything has to be pretty precise and accurate. It can't be just like, oh, it's close enough, right? Well, how far is it from here to there? Oh, it's close enough. Or when you play a football game, you're like, oh, someone tackles the opponent, right? Let's say we tackle the opponent. The football never makes it to their touchdown. But the refs are like, touchdown! And then our team is all like, what? Doesn't even make it across. And the ref is like, well, it's close enough. How would that make you feel?
I'd be mad.
You'd be mad, right? That's ridiculous, right? So what if it was on our side, though? Let's say we got the touchdown. How would that make you feel? Happy. But does that make you feel like you won fairly?
Yes.
No, it's not really a game. If we lose the rules in football to bad measurements and precision, then we won't have fun. Rules if we don't follow the rules in a game, the game kind of becomes pointless, okay? So, in the same way we build buildings, okay, let's say that they built these 4 walls, right? In our classroom, let's say that all these walls are the same height, except that wall is like, 3 inches lower. Okay? What happens if that wall's 3 inches lower? The roof could fall, or what's going to happen? Do you think we'll have a gap there?
Yes.
Yeah, and then there's going to be like all these like mice and rats that'll come into our room and start eating at our feet. No, that's not going to happen. That's gross. Okay? All right. Anyways, we have to be precise for the safety of things, okay? So you have to we do apply that in real life. Or even like look at something as fine as our clothes, right? So when they sew our clothes together, or your shoes, right? Don't you think they have to be accurate? What happens if one of your shoes is off by a little bit? Don't you think that would look kind of weird on your feet? Would you be happy if one of your shoes is not accurate or precisely measured? No, it's going to feel bad. Maybe your toe is going to get squished. And people are going to look at you and be like, what's wrong with your feet? And you're going to be like, I don't know. And you're going to be hiding, right? So we don't want that to happen. Anyways, that's why this is important. There's a couple pieces of vocabulary that are there. Precision is the level of detail an instrument can measure, and significant detail is the digits in a measurement that carry meaning, okay? So measuring with precision, looking up here, which is more precise, having 2.3 liters or 2,344 milliliters? Which one is more precise? Well, I think that the one that's more detailed is the smaller details are always more precise, right? Smaller details are more precise. So I think that milliliters is the smaller detail, so milliliters is more precise, okay? Or let's think of the football field. What's more precise if I were to measure 12 yards or 37 feet? Which one's the smaller detail, yards or feet? Good, so this is the more precise measurement, right? Does that make sense? So yeah, you could say I ran the ball 12 yards. But what if you really ran it a little farther? What if you ran it a little bit farther? It's more precise to say I ran 37 feet. Does that make sense, everyone?
Yes.
Okay, turn to your neighbor really quick. Tell him what does precise, what is the question? What does precision mean to you? Ready, go. Continuing on. Okay. How about these two? Number 3. Let's just take a hands. There's 2.88 liters and 2,883 milliliters. Raise your hand if you think 2.88 liters is more accurate or precise. Raise your hand if you say 2,883 milliliters is more precise. Okay, good. Excellent. So this one would be more precise. Right? That one's more precise because it's a smaller unit. Okay? What about number 4? Raise your hand if you say 6 feet is more accurate than 74.3 inches. Which one's more accurate? Raise your hand if you say 74.3 inches. Right? Inches is more detailed, right? And it's even more detailed. It has a 0.3 or a 3/10 inch, okay? So this is really the better way to go, okay? So that's something on precision, right? And I'm going quickly through precision because this is kind of one of those duh things, and it takes a little extra work, right? It takes a little extra work to be precise in life, okay? It takes a little extra work to precisely measure things. You can't just be like, how big is your foot? Oh, my foot's like, I don't know, like this big. Right? Is that precise? No, you have to get a measuring device. Oh, what is that? From your elbow to your wrist? Is that how big my foot is? No, that is way bigger than my foot. Do it?
It's not that big.
No, it's not. It's shorter. It's my old shoe. They make me taller?
It is.
They make me taller. Not for me. I have longer arms. Okay. Anyways, so clearly we can't measure people by the size of their arm for their shoe. Okay? Continuing on. Significant digit steps. These are steps that you need to write down. If you're watching the video, please pause now, write these down. So, significant digit steps are really important. Things that are significant, or the digits or the places on the number, are important to the smallest bit of accuracy. So let's just say that, we're going to measure two things together, and let's say I'm measuring to the nearest tenth of an inch for something, and then someone else is measuring to the nearest thousandth of an inch. Because mine is less accurate or less precise, we got to downgrade it to ours, right? Or another way to look at it is like, this happened to me. I have a Wii at home, Nintendo Wii, okay? And I have a brand new TV. It's got the HD 1080 HD, right? But what's wrong with my Wii? My Wii is, it doesn't produce 1080. What is it? 720. So am I going to get 1080 picture because of my Wii? No, why not? Because it sucks, right? Even though I have the best TV that's out there right now, all I'm getting is 720. Does that make sense? Okay, that's the same thing. The only thing that's significant is the Wii. That's what's holding us down, okay? So the one that's less significant is going to be it's the precise measurement. Even though the TV is able to do even finer precision, we can only assume the most precise part is the Wii. Yep.
You should get a PS4.
I should. Good. Okay. We could. I'm sure maybe some of us have played with each other online. You never know. I was the guy that was always working you kids. Alright, anyways, here we go. Significant digits, okay? The first thing, look up here, significant digits, okay? This is like us figuring out what kind of precision does our TV have. Is it 1080, 720, 480? Or is it old school like 4x3? Okay, so what's the most significant digit? Watch up here. This is the same thing. We just look at the last digit. This is the tenths place. So the significant digit is the hundredths place. Okay, hundredths. Okay, that's the most significant. Is it going to be any more detailed than hundredths? Is it going to go to thousandths? No, it's not. Because is there a number there that's telling me that? Is there a number there for thousands? No, since it doesn't exist, then it's not there. Just like our Wii doesn't go to 1080, this number doesn't go to thousandths. Does that make sense? Okay? Or look at number 2. We got 70 ten thousandths. What's the most significant digit? Well, it's this 10,000 spot, okay? So this one's more accurate than the last number, okay? So why don't you turn to your neighbor really quick, tell them what you think significant digits are to you, and you could use my example, and then you can write this down. Ready, set, go. Okay, turn to your neighbor, tell them what's the most significant detail. Okay, what is it, everyone? Tenths, right? This one is the tenths. Good. Next one, number 4. What's the most significant digit? No, 1/1000. Okay, so you see how you're making a silly mistake? You might be calling it thousandths. Okay, that's enough of that sound. Thank you. That was good. I don't know who's doing that. That was well done, but thousandths. Okay? Okay, continuing here. Okay, word problem. This one's a little harder. You measure a rectangle window to the nearest tenth of a centimeter and find the length is 83.4 centimeters. Okay? A friend measures the width to the nearest centimeter and it finds that the width is 39 centimeters. So did he measure more accurately or less accurately? Less, right? Did he go by tenths or did he go by whole ones? Okay, so use the correct number of significant digits to write the perimeter and area of the window. So looking back on our steps, before that, how do we measure how do we measure perimeter? Don't you just add all the sides up? Would you all agree?
Yeah.
Okay, looking back at our directions here, we said when adding or subtracting, we round the answer to the least precise measurement. What the least precise measurement we said was the ones place, right? So we're going to go back to the word problem and we're going to think about this window. Okay? We said that the width of the window was 83.4. Which means the top is also 83.4. And the width is 39. Okay, so we add them all together. So you would do a side problem. We got 83.4 plus 39.0, or 39. We know that there's a decimal point there. Then we have 83.4, and then 39 again. Okay? Let's have you add these up together. I'll call on you to give me your answer. Ready, go. When you add this, you'll get 244.8, right? But what were the directions? It says round to the nearest significant digit. What's our significant digit? Was it tenths or ones? Who measured less accurately? You or the friend? The friend. So we have to go down to that. Remember, like the Nintendo, even though we have a 1080 TV that could make it look real sharp, our Wii is like kind of lame, right? Does it produce the 1080? No. So, which one is less accurate, you or the friend?
Friend.
The friend, right? And what did they measure to? To tenths or to ones?
Ones.
Ones. So we have to measure to the nearest ones place. Look at the number on the right of the ones. Is it 5 or more?
Yeah.
Yeah, so we round up, right? So it's going to be 245 centimeters. Okay? That's it. Okay? Alright, so that's it. Well, that's all we're going to do today for precision and accuracy. That's the end of the lesson.